Hey everyone, this is Miss Moyer with 16.7 Operations in Scientific Notation, Part 2, Adding and Subtracting. For adding and subtracting numbers in scientific notation, we really need to rely on the distributive property. So we know the distributive property rule looks like this. And way back in Chapter 3, we learned about factoring. So for example, if I have 20 plus 30, I know that both of those numbers are multiples of 10. This is 2 times 10, 30 is 3 times 10, and yes, I can just say 20 plus 30 is 50, but I also can say I can factor out a number and turn this into 2 plus 3 times 10. So we're going to use this idea when we deal with numbers in scientific notation. So here we have 4.6 times 10 to the third plus 8.72 times 10 to the third. So here, because our operation in the middle is different than these other two, we can't use some of the same tricks that we used in the multiplying and dividing. What we have to do is say, what do these two numbers have in common? They are both being multiplied by 10 to the third. So this is the same as saying 4.6 plus 8.72 all together times 10 to the third. Remember, if you're feeling a little skeptical about this, remember that if we distributed this back, this 10 to the third back in, we would get back to where we started. So it really does give you an equivalent expression. So now that we've got that, all we have to do is add these numbers up. So 8.72 plus 4.6 gives us 13.32 times 10 to the third. Now, we are sadly not in scientific notation, so we have more work to do. So just like we did in multiplying and dividing, you're going to take that factor and rewrite it in scientific notation. To get it back to where that decimal point is supposed to go, it has to go 1 to the right. So this is times 10 to the first. And then when we put this all together, we get our final answer of 1.332 times 10. 1 plus 3 is 4 times 10 to the fourth. Before our next example, I just wanted to touch base a little bit about factoring. We had these factoring problems way back in Chapter 3. And remember how we talked about them. We needed to turn them into something times some stuff in parentheses. So we were factoring out here, we'd factor out a 3. And so to figure out what the two terms were that are being added up, we took each term and divided it by 3. So this first term becomes just the x, 1x. 6 divided by 3 gives us 2. So remember, when we're doing this factoring, really each term, each thing that's being added up gets divided by the number we're factoring out. And that's really important for the second example here under the addition and subtraction examples, because here you may notice when we're subtracting 3.5 times 10 to the negative second minus 6.6 times 10 to the negative third, they don't have the same power of 10. So the strategy we used on the last one of just, well, they have the same power of 10, let's factor that out, it doesn't work. So what we need to do is to choose the greater power of 10. And why we do this is because it makes less work than factoring out the smaller one. So it doesn't really matter that much, but if you factor out the greater power of 10, you usually have less converting to do once you're done. Like you're more likely to end up with your answer already in scientific notation. So we're going to factor out 10 to the negative second. So in essence, each term is going to be divided by 10 to the negative second. And that's going to allow us to turn our statement into this factored form. So on the left, or 3.5 times 10 to the negative second, when we divide this out, that just becomes 1. So we're left with 3.5. And the second one, our 6.6, when we do that division, we're left with 6.6 times 10 to the negative 3 minus negative 2 is negative 1. So we aren't left with a standard form number yet. We have to convert it so that we'll be able to do that subtraction in the parentheses. So we get 3.5 minus 0.66 times 10 to the negative second. So off to the side here, I'll do my arithmetic. And we end up with, we have to borrow. So 10 minus 6 is 4, 14 minus 6 is 8, 3 minus 0 is 3. So we get 3.84 times 10 to the negative second, and that's our final answer. So here's your chance to give it a try. I know this stuff can be pretty tricky. Pause the video, give it a try, and then unpause to check your answers. So I did the first one. The first one does not have the same power of 10. So take a look. In fact, they're very different powers of 10. I chose the greater one. So I chose to factor out 10 to the second. And as I went through that, that made the second number here, this 3.41 times the power of 10, into a really small power of 10, 10 to the negative third. So it ended up working out just fine. Here's the second one. The second one is a good proof that just because it's addition or subtraction, it doesn't mean that it's going to be a huge, crazy, complicated problem. In this case, we had the same factors of, or same products, say that again, same powers of 10 on both numbers that are being subtracted. Easy to factor out. No crazy stuff to do down here. It's just a simple subtraction, and you get right to your answer. Okay, your assignment is page 752, numbers 7 through 13 odd. I want to remind you that there is going to be extra help with Miss Moyer on Wednesday at 9 a.m., 9 to 10. If you need help, this stuff is tricky. This is stuff the kids need a lot of help with when we're in school, and here you are at home trying to learn this stuff. So ask questions, come to a Google Meet, email your teacher, and this was your last math instructional video planned for the school year. Wow. Hope you have a great rest of your day, and I hope to see you soon.